Hey everyone! Today we're learning domain and range of continuous graphs. Alright, so first you gotta know what continuous means. That just means it is connected by a line. There are no breaks. Notice every single example on this page meets that description. Alright, so before when we did the discrete graphs, we made a list of all the x's and we made a list of all of the y's, and that was our domain and range. Okay, for these it's a little bit trickier because we are filling in all the numbers in between. And so our answer needs to be an interval, kind of like what we did with our inequalities before when we graphed those. All right, so for the domain, let's fill this in. You scan your pencil left to right. All right, so domain is the x's. The x's run from left to right. Okay, so as you're going from left to right, you identify the x values anywhere that's touching the graph. Now for the range, you're going up. You're going from the bottom up. And so I'm going to change this. So scan your pencil from bottom to top. And identify the y values in which you are touching the graph. All right, so domain goes this way, range goes this way. So you're basically coming up with the width of your graph for the domain, and the range is telling you basically the length of your graph. So we're going to look at these. All right, number one. The first thing I want you to notice about number one is that we have arrows on the ends. Okay? So we need to remember what these arrows mean. So make a note over here on the side. Arrows imply infinity. Okay, infinity just means it's going on and on and on and on forever and ever and ever. What this means is that in each direction the arrow is pointing, it's going to continue going forever and on and on and on and on and on. All right. So we need to figure out all the x values that this line will cover. Now here's what I know. X goes from left to right. So it said to use your pencil. Sometimes I use a piece of paper like I did for our number line test. So let's try this. So if I'm going from the left, because there's an arrow here, it's going to keep going left forever. Right? That's what the arrow means. So it's going to keep going left forever. And then as I travel this way, it's going to keep going right forever. So I can assume it's going to be all of the negative values, all the negative x values, and all the positive x values. And so a real easy way of saying this is all real numbers. So remember, that's our little symbol for all real numbers. You could also write out all real numbers. Okay? Another way to write this, using inequalities as a compound inequality, would be like this. Negative infinity to infinity. Now think about what this means. This is saying that x is in between negative infinity and infinity. And that's true. X can be any number basically on the x-axis, any of those numbers, because it's going left and right forever. There's another way to write this too. So this is our inequality notation. There's also something called interval notation. And so we are going to talk about that as well on the back. Okay, so I want you to flip, and we're going to write this on the front, okay, to where it looks like this, like a book. Okay, so domain and range notation. We're going to start with interval notation. So on that other side, we had negative infinity is less than x is less than positive infinity. Now, if we wrote this in interval notation, it would look like this. Negative infinity to infinity. So it's written like an ordered pair, but these mean the same thing. Now, one thing you need to know about interval notation with infinity symbols, okay? When you have infinity as a part of the domain and range, the domain or range, you must use parentheses. Okay. So in interval notation, the parentheses mean that this number is not included. Now, we can't include infinity because it goes on forever. So that's why we always use parentheses. Okay, so here's another way of writing the exact same thing. So let's flip back and let's figure out the range. All right, so the range, we're going from the bottom to the top, and this describes the y values. Okay, that's very important, because notice how I wrote an x here. When I do the range, I'm going to write y. Okay, so we're going from the bottom to the top, so I make my way up. So notice I'm not touching any of the graph yet, and then boom, right there, touch the graph. Okay, that's the start of my range. Right here, what is the y value? So I look at the y-axis to tell me it's -2. So the range actually has a starting point. It starts at -2. So we're not going to use all real numbers. We're not going to use infinity yet, because we start with -2. Okay? So to use my inequality notation, y is always in the middle, and then I have a less than. Okay, so I need to figure out, is -2 included on this graph? Yes. So I need to make sure to include it on my inequality. So it needs to be less than or equal to. Now, as I keep moving up, I notice I have arrows on the end, so that means this is going to keep going up and up and up and up forever. How do we denote forever? Well, we use an infinity. If it's going up, it's positive infinity. If it's going down, negative infinity. So less than infinity. Now keep in mind, whenever I have an infinity, I'm not including it with an equal sign, because infinity cannot be reached, so I can't include infinity because it's not really a number. So that's how I would write the range. Now let's go back to our other side and let's figure out how we would write it in interval notation. Okay, so if I have a range for number 1 of -2, this is what we had written down. The way to write this in interval notation would be to use a bracket for -2, infinity, and then a parentheses. These two things mean the exact same thing. Now, we didn't talk about brackets before, so let's make a note. Okay? Brackets are used for any included number. Now remember, we said infinity is not a number, okay? It's more of a concept. Infinity forever. All right, so you only use brackets if you have a less than or equal to. And they can be used on either side. It just depends on where the equal to is. And that's it. That's interval notation. Let's go to number 2. All right, the first thing you need to be looking for is arrows. Does number 2 have arrows? No, it's a circle. There's no arrows pointing off of it anywhere. So let's do our domain first. Where's my piece of paper? Okay, so we're going from left to right. So I travel to the left, and then there I see the circle starts. Okay, this is the start of my domain. That's at -3. So remember, I'm looking at the x's for the domain because domain is x, just like we said before. So domain starts at -3. I keep moving, and then it ends here. Here, our domain is 1, 2, 3. So from -3 to 3, all my x's are included. So let's set it up. Let's write it like this. Okay, so we start with -3. Always start with the smaller number and end with the bigger number. Now let's decide if we should make this a less than or equal to. So because this is nice solid lines, the 3's are included, so I need to make sure it's equal to. Okay, if you had an open circle or a dotted line, then you would not make this equal to. All right, so that's the domain range. We're going up. Up, we start right here. So that is the lowest point on my graph, and that is -3. And then as I travel upwards, the highest point on my graph is right here, and that is 3. So in this case, the domain and range should be equivalent. So it's a -3 is less than or equal to y less than or equal to 3. Now, how would we write this in set notation? Well, for the range, it would be brackets on both ends because they're both equal to, and it would go -3, 3. You always put the smaller number first. That would be the range. The domain would be exactly the same. -3 to 3 in brackets. All right. So I want you to try 3 and 4, and then wait to see and double check it. All right, you should have paused the video, and now we are going over 3 and 4. Now the first thing you should notice about number 3 is these arrows. Okay, arrows imply infinity. So infinity is going to be used in here somewhere. Now for the domain, I'm going from left to right, and I can see there's an arrow going forever to the left, including all of my negative numbers, and there is an arrow going forever to the right, including all of my positive numbers. So this is another instance like number 1 where the domain is all real numbers. So you could put all real numbers, the word, the little r thing, or you could write -infinity to infinity, or you could use set notation, -infinity to infinity with parentheses because you can't include infinity because it's not a number. If I'm doing the range, I'm going up and down. So we start from the bottom up, and I can see that this is going down. Right? It's going to continue to go down and down and down and down forever and ever and ever. Just like it's going to continue to go up forever and ever if I keep extending this line. So if it's going down forever and up forever, the range is also all real numbers. All real numbers, -infinity, but instead of x, I'm describing y to infinity. Oh, I'm running over into the other one. And I can use the same set notation, negative infinity to infinity. So for number 4, this one's a lot like number 1. For the domain, we're going left to right. Notice I have arrows. So it's going to go left forever because this is going to keep getting wider, right? It started really narrow and then it got wider. So I can assume that it's going to keep getting wider forever and ever and ever. So it's going to the left forever and it's going to the right forever. So I also have a domain of all real numbers. All real numbers. Let me use this pen. You could put all real numbers or one of these options as well. The range is how far up and down. So remember, we start from the bottom to the top. So I start from the bottom. I can see that it's going down forever and ever and ever and ever and always. Okay, so I don't actually reach the bottom. So that means I call that negative infinity. So it's going to negative infinity forever. But is it going up forever? No, I don't have a single arrow pointing up. It stops right here. Do you see that? This is the top of my range. So I count to figure out what that number is using the y-axis. So 1, 2, 3, 4, 5. So I'm going from negative infinity to 5, including the 5 because this is solid. So negative infinity is less than y is less than or equal to 5. So remember, no equal to on the negative infinity, equal to on the 5. So to write this in in interval notation, it would be negative infinity with a parentheses and then 5 with a bracket because the brackets are when it's included. All right, try the next two. Okay. Let's take a look here. We have this weird diamond thing going on, but no arrows. So number 5 is a lot like number 2 in that way that there's no arrows. So I should have numbers on either side. So the domain is left to right. My graph starts here and it ends here. That's the width of the graph. So this should be negative 1, and this should be 1, 2, 3, 4, 5. So my domain goes from negative 1 to 5. These are solid lines, so I need to use the equal to. And because we're talking about domain, it should be x. So less than or equal to negative 1, less than or equal to 5. To write this in interval notation, I would use 2 brackets. It would go negative 1 and 5. Just like that. The range, go from the bottom up. So we start down here, because that's the lowest point on my graph. And that is going to be a y value. So I look at the y-axis, 1, 2, 3, negative 3. And then I stop right here. That's the top of my graph. That's 1, 2, 3. So the range is different. It's starting at negative 3 and it ends at 3. So negative 3, solid lines again. So I use a less than or equal to. Range is the y values. And to write this in interval notation, it's negative 3, 3. Number 6, we do have arrows. We have arrows. So I need to take that into account. For the domain, left to right. So I can see that this arrow is going to make this go left forever. And this arrow is going to make the graph go right forever. So The domain is the same it was for number 1 and for number 3. The domain is all real numbers again. So all real numbers, here I've been using black for domain, I don't want to mess it up. So all real numbers, you could put this notation or this notation. They all mean the same thing. All real numbers, and then the range goes from the bottom up. So I can see that this is going down forever, and then this is going up forever. So I don't need to take where it stops here into account. A lot of students think that this is like the end of the range. I have to think about there's more of the graph that's still going up. So I have to take into account the entire graph. So it's still going up forever, it's going down forever. That's also all real numbers. So in this case, my domain and range is infinity, forever, real numbers, all of them. And that's it. So there's a back side to this. I want to do one more with you. All right, so let's look at number 11, and then I'll have you do the rest on your own. Okay, for number 11, we have a closed circle here. You have to really pay attention to the details. Then we have an open circle, okay? Open circles, okay? Not included. So that's going to affect your notation. Open circles are not included. So here, when I'm trying to figure out my domain, the domain starts here. Just draw a line to show that. At -2, because remember we're looking at the x-axis for domain. And on the right side, because we're going left to right, the domain goes here. But it's an open circle. So open means it's not included, but the number is 1, 2, 3, 4, 5. So we're going from -2 to 5, where 5 is not included. So if we used interval notation, it would have a bracket at -2 and a parentheses at 5. If we use the inequalities notation, remember we have an x in the middle, it would be an equal to, less than on the left side, and then a less than without the equal to on the right. Because remember, we go from the smallest number to the highest, so it's -2 to 5. And then the range is how far up it's going. And so this one doesn't have a very far range because it's kind of small. So the lowest part is here. Okay, the y value for this pink line is -2. And then for the top of this line, it stops there, that's the highest point. And that's +1. So we're going from -2 to 1. Now, this is an open circle. So is the -2 included? No. So same thing as before. Some things are included, some things aren't. This is a solid line at the 1, so the 1 is included where the -2 is not. So -2 is less than y, no equal to, is less than or equal to 1. This is included because it's solid. This is not included because it's open. And this interval notation would look like this. A bracket at the 1, a parentheses at the -2. All right, do the rest. Pause the video. All right, check your answers with mine. If you used interval notation, look at what I have written in pink to check your work. If you wrote all your answers in inequality notation, then you need to look at what I've written in black. All right, that's it for this video. Good luck on your homework.